Have you ever wondered what would happen if we could create a neutron star? A neutron star is one of the most extreme objects in this universe. It packs more mass than our sun into a sphere only about 20 kilometers wide. Today, we are going to build a neutron star model in Universe Sandbox and learn the fascinating astrophysics behind this cosmic chain. Before we begin, it's important to understand that neutron star cannot be artificially created by humans. They are burned naturally when massive stars die in spectacular explosion called supernova. Let's start with a massive star. A star spends most of its life converting hydrogen into helium through nuclear fusion. This fusion produces energy that pushes outward against gravity. As long as fusion continues, the stars remain stable. Over millions of years, the star begins fusing heavier and heavier elements. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and eventually the star produces iron in its core. At this point, the star faces a serious problem, unlike lighter elements. Iron cannot release energy through fusion. The star's energy production begins to fail, and gravity starts to win. The core collapses at incredible speed. In less than a second, the central region of the star is compressed to extreme densities. Electron and proton are squeezed together, forming neutrons. Inside the collapsing core, a remarkable reaction occurs, that is, protons combine with electrons to create neutrons and neutrinos. This process transforms the stellar core into an enormous ball of densely packed neutrons. The outer layer of the star crashed inward and then rebounded outward in a tremendous explosion known as supernova. The explosion can briefly outshine an entire galaxy. After the explosion, only the collapsed core remains. This remnant is what we call a neutron star. Notice its tiny size compared with ordinary stars. Even though it is only about 20 kilometers across, it may contain more mass than our sun. To understand how dense this object is, imagine compressing the entire mass of the sun in a city-sized sphere. The resulting density is almost impossible to imagine. If we could bring a spoon of neutron star material to Earth, it would weigh roughly 1 billion tons. That's more than the mass of many mountains compared into a single spoon. Gravity on the surface of a neutron star is extraordinary. A person standing there would be pulled apart instantly. The escape velocity is so high and light itself struggles to escape, though not enough to form a black hole. Many neutron stars rotate extremely or rapidly. Some spin hundreds of times every second. These rapidly rotating neutron stars are known as pulsars. When a pulsar rotates, the beam of rotation sweeps through space like a cosmic lighthouse. If one of these beams points towards Earth, astronomers observe the regular pulses of radio waves, X-rays, or gamma rays. Some neutron stars possess magnetic fields trillions of times stronger than the Earth magnetic field. These objects are called magnetars. Magnetars are among the most powerful magnetic objects known in this universe. Their magnetic fields are so strong that they can distort atoms and generate enormous bursts of energy. What would happen if Earth suddenly became a neutron star? Its diameter would shrink from over 12,000 kilometers to only a few tens of meters, while keeping the same mass. The gravity near the surface would become extreme, and life as we know it would instantly disappear. Scientists continue studying neutron stars because they provide natural laboratories for testing physics under the conditions impossible to reproduce on Earth. Deep inside this object, matter exists in the form that remains mysterious even today. Could there be exotic particles inside neutron stars? Could their core contain quark matter? These questions remain active areas of astrophysical research. Neutron stars are not just stellar remnants. They are gateway to understanding the gravity, nuclear physics, and the fundamental structure of matter. Thank you for watching. If you enjoy this journey into the world of neutron stars, subscribe to Beyond Earth for more videos on black hole, dark matter, exoplanet, and the deepest mystery of the universe.